Hi, this is Professor Charles Kaplan again, retired. I taught economics and applied math for about 20 years at the undergraduate and graduate level here in New York. I'm putting up these videos so that students worldwide can learn math and economics a little bit better. I'm also available for private tutoring through the Wyzant website, W-Y-Z-A-N-T. You can find me under Charles Kaplan, K-A-P-L-A-N. Okay, so we're doing normal distribution problems. This is the second of two videos I'm putting up on the normal distribution. Remember, the normal distribution is a symmetric bell-shaped curve with 50% of all observations lying to the left and 50% of all observations lying to the right of the mean. And we're going to standardize it. We're doing the standard normal distribution, which is transforming our x variable to a z variable. And I'll show you how to do that in a moment. And the best way to do it is to probably just jump right in. So we're going to write down the information we're given, draw a picture, and then solve. So the average salary for a full-time college professor is $140,000. So mu equals 140. Normally distributed, standard deviation of 11,000. So we know that 140 is the mean. I'll leave out the 3 zeros for clarity here, so I don't clutter it up. And here it wants to know the probability a professor earns more than 170,000. So, like so. Drawing the picture is very important. It shows us exactly what we're doing. And we know that z is equal to x minus mu over sigma. And in the standard normal distribution, the mean is 0. And the standard deviation, by the way, is 1. Okay, so x minus mu over sigma, z is equal to 170,000 less 140,000 over 11,000. If we do that, I've worked it out ahead of time, we get a z-score of 2.72. So 2.72, we can fill that in right here, is z. And this is one reason drawing a picture comes in so handy. We can match the picture up with our z-table picture. In this case, it's the left tail, but it doesn't matter whether it's the right tail or the left tail. And we're looking for a z value of 2.72, so it's going to be a mighty small area. So 2.7, and we go over to the second column, 2.72 is 0.0033. 0.0033. So this area is 0.0033. So the probability that x is greater than 170,000 is 0.0033. There's your solution to this one. So just first thing we do, we write down the information we're given. In this case, mu is 140, sigma is 11, 11,000, 140,000. We draw a picture, make sure we shade in the area that we're interested in. We calculate our z value. Then we go to the table, we look for the area associated with a z-value of 2.72. In this case, it's 0.0033, and that's our solution. So now, here's the next one. Same information about a college professor. So mu is equal to 140. Sigma is equal to 11,000. And it wants to know the probability a professor earns less than 90,000. X such that X is less than 90,000. Draw our picture. This is 140, 90, less than 90,000. This is 0, X, Z. Let's go ahead and find our Z value. So Z is equal to X minus mu over sigma. So Z is equal to 90,000 less 140,000 over 11,000. And if you do that, we get a Z value of 4.55. All right, that is a very small number. So what I did was, that's going to be approximately 0, but we know it's not going to be 0, so you have to pick something. When you get something like 4.55, you could say it's approximately 0, but in this case, I looked up the exact value, or as near as I can get to an exact value, because it is an approximation. This is a continuous curve, and so we're never going to get an exact value, but in this case, it is approximately 0.1234127. So here it is. In this case, it'll be negative 0.0000127. That is the area associated with a Z value of 4.55. Now, just to give you an idea of what that 4.55 means, based on the empirical rule, plus or minus 1 standard deviation from the mean is 68.26% of all observations. Plus or minus 2 standard deviations from the mean is, just give me a calculator, it's, I think, 5.4, let me just check, 0.4772, 0.9544, so 95.44% of all observations are plus or minus 2 standard deviations from the mean, and plus or minus 3 standard deviations from the mean is 0.9974. 99.74% of all observations are within plus or minus 3 standard deviations from the mean. So you're pretty much you're getting very close to 100% at 3 standard deviations. At 4.5 standard deviations from the mean, let's see, 10, 100,000, 10,000, 100,000, a million, 10, 127 out of a million, out of, what is this, 10 million? 10, 100,000, 10, 100,000, 100,000, million, 10 million. 127 out of 100 million is 127 over 100. That's the probability of landing in this tail if it's 4.55 standard deviations from the mean. So a very tiny area. Okay. Let's see what this question asks us. So again, mu is 140, sigma's 11,000, and it wants to know about a salary between 125,000 and 160,000. So this is what our picture looks like. That's the area we're looking for. We're going to have to get z values for both of these numbers. That's x minus mu over sigma. So let's see, 125,000z is equal to 125 minus 140 over 11,000. Z is equal to 160 less 140 over 11,000. Okay. So the 125, I have these worked out, is negative 1.36. And the 160,000 is 1.82. So now we need an area for here and an area for there. So let's go to the table with the center colored in, because that's what matches both of these. And let's see, 1.36. We're going to go to 1.3 and over to 6, and that's 0.4131. And then 1.82. 1.82 is 0.4656. Okay. So now what we're going to do is we're going to add these two up. So the probability is 0.4131 plus 0.4656. And if you add them up, that goes to 0.8787. So there's the probability. The probability that x is between 125,000 and 160,000 is 0.8787. Okay. Let's see. We have another problem here. Looks like we have two more after this one. Okay, so same thing with the college professor. The mean salary mu is 140,000. Sigma is 11,000, and it wants to know the probability that we're between 150 and 170. So that's what the picture looks like. And we know that z is equal to x minus mu over sigma. So let's get our two Z values. Z is equal to 150,000 minus 140,000 over 11,000. And Z is equal to 170 less 140 over 11,000. And if you do that, the 150 is 0.91, and the 170 is 2.72. So now what we need is an area for there, an area for there, and that'll give us an area for the middle part there. So let's see, let's get this is the table we use, and we want 0.91. So let's go to 0.91 is 0.3186. So 0.3186. And then 2.72, 2.7, and over to 2 is 0.4967. So what we're going to do is we're going to go down here. We're going to take, the probability is going to be 0.4967 less 0.3186. And that's going to give us 0.1781. Oops. All right, so I made a little faux pas here. This should be 0.4967 down here. And the area is 0.1781. So what I did was I took the area from the mean to here, larger area, and then I subtracted off the area from the mean to here, the smaller area, and that gave us this area, the difference between the two, which is 0.1781. So, okay, so that's that problem. Two more. So, now we want the 90th percentile. So we know that mu is equal to 140 and sigma is equal to 11,000. .10. So we have 10% in the tail here. And we know that zero's there, x, z. We know that, let's go to our z table with the tail. And we're looking for 0.10, an area of 0.10. And if we do that, we can come over to 1.28, which is 0.1003, which is 3 10,000ths off. It's pretty close. So 1.28, 1.2, and over to the 8th column. 1.28 is our z value. So 1.28, and we're going to try to find our x value now. So we know that z is equal to x minus mu over sigma. Well, we know what z is. We know it's 1.28. So 1.28 is equal to x, which we don't know, minus 140,000 over 11,000. So, let's see. I need a calculator because I don't like the, let's see, 11,000 times 1.28 is 14,080. X minus 140,000. We add 140,000 to each side. And we get X is equal to 154,080. So the 90th percentile, the cutoff, is $154,080. Whoa. 154,080. So 154,080 with a 1.28 Z value. And that's the 90th percentile. Now, the last question asked us to find the bottom 20%. All right, so here's what it's asking us for. It wants, essentially what it's asking for is, what's the cutoff salary for the bottom 20% of earners who are college professors? That's what it's asking for. So now what we need to do is we need to go into the table, this table, and look for 0.20. And if you do that, you're going to find it's a 0.84 is about as close as you're going to get using this table. So 0.84 or negative 0.84, that's important in this case. Negative 0.84 is the Z value. Whoop, okay. Kind of reverse that there. So Z is equal to X minus mu over sigma. So we know what Z is. Z is negative 0.84. And that's equal to X, which we don't know, minus 140,000 over 11,000. So we do that. This is equal to negative 9240 is equal to X minus 140,000. So X, if we add 140,000 each side, is equal to 130,760. So the bottom 20%, I don't know what the bottom 1% earns, but the people at about the 20% mark earn $130,760 as college professors. So, okay, so that's our last question, 137.60. That's our last question. This is Professor Charles Kaplan, retired, taught economics and applied math at the undergraduate and graduate levels here in New York for about 20 years. And bringing these videos so people around the world can have a resource to learn math and economics. If you want private tutoring, I am available on Wyzant, W-Y-Z-A-N-T. And you can look me up, Charles Kaplan, K-A-P-L-A-N. And aside from that, I hope you have a wonderful, healthy, happy day today, and that you have a great life ahead of you. That's all, folks. Have a good evening, or a good day, I should say. Bye-bye.